Right. Good afternoon, everyone. Are you guys having a good summit so far? Doesn't look like it. Are you guys really having a good summit so far? Yeah. That's more like it. Keep your energy levels up. We're going to have some fun in this session today. Just to kind of introduce the level and the topic here, we're going to talk about big data in the cloud. We're going to talk about three primary aspects, as the title says. We're going to talk about the what, the why, and the how. All right? Now, the agenda is pretty simple. That's what we're going to talk about. Right? Just to introduce myself, I'm Nishant Thacker. I'm a technical product manager for all the big data services at Microsoft. Just a fancy title there. Just means that I work with a lot of you folks in my daily job, trying to get you to implement your big data solutions on the Azure platform, which is the public cloud offering from Azure. Okay? Now, just talking about this whole concept of big data in the cloud is quite cumbersome. And we've tried doing this a number of times before, and every time we receive feedback that, why don't you show something in action? Well, I take that feedback. I'm going to dive into a quick demo right up front. Now pay attention to this demo because I'm going to tie this demo back to individual pieces of my talk as we go along, right? So let's switch quickly to my screen over here. And here I am. Now, this is a financial services firm, Woodgrove Financial Services. Deals with a lot of securities data, manages all of that in space. Again, deals with data in the forms of tens, if not hundreds of terabytes in nature, and does a lot of machine learning to determine certain patterns within trades as well as with customers and if there is anything suspicious going on around that space. Now, why am I stuck on this particular screen over here? The first screen up here is for the login. What this infers is the security aspect of a big data solution. The first screen that I'm looking at is actually integrated with Active Directory in particular. I have a login here, I have a password, it's connected to my organizational IDs, and I can sign in. I only get access to the data that I need to view. In this case, I have a bunch of data points coming through. The streaming data points of the indices, the Dow, the NASDAQ, the S&P, etc. If any of you have mobile phones, just check it around. These are live feeds coming as we speak right now. Okay? There are stock quotes coming in, of course. The first one over there, CTOS, stands for Microsoft's favorite Contoso stock. That's the dummy stock fed in over there. But the rest of the stocks are all real over there. And all the feeds coming in are also real. Now just imagine, for one of these analysts trying to analyze about 20 terabytes of data for about 4 or 5 of their managed accounts. Just imagine a financial services firm like Woodgrove with hundreds of such analysts trying to bring together all of the data and trying to crunch all of it to give you that analysis. Look at the sector summary over there, splitting it across by industries. And in particular, look at the percentage of client revenue, which is actually doing an analysis over the years. In this case, just showing about 3 years up there. And it's showing how the split of the data or the split of the investment has gone through from, let's say, healthcare and energy onto financials and energy as a maximum over the last couple of years or so. What's also interesting are the news feeds and the video feeds. Now, mind you, this is not just a normal pull from one of those feeds that's coming through. This is actually going through some cognitive capabilities to determine if these feeds are actually relevant for the topic of discussion on the screen right now, and only then do they get shown on our feeds over here. So in essence, cognitive services are employed to go ahead and read the text of an article to determine what is the relevance to a particular subject area or a topic. And if that is relevant to the financial services sector, only then does it show up on this page. And just imagine all of this happening across the web crawl of all of these videos and news feeds coming through in real time. Now that's the magnanimity of big data in action. And to tell you something about the backend, all of this is on the cloud. Not even one element happening outside of it. We use cognitive services for all of the cognitive capabilities. We use Azure Machine Learning and our server for all the machine learning capabilities. We use HD Insight in Azure for all the Spark and Hadoop capabilities. We use Azure Data Lake, Store and Analytics for all the big data storage and analysis capabilities. And we use SQL Data Warehouse as the front end to support all of your reporting and app capabilities up there. Now, given that, I could even dive into one of these particular clients to see some of these action. I talked about machine learning. Here, I see a customer churn score. I see a risk score. All of that coming from the data that's being crunched across magnanimous amounts from various platforms as well as various customers. Now let's just go ahead and switch our roles. I'll sign out as Jeff Phillips and log in as Robert. In this case, I'm now even getting data for the individual advisors in addition to data for geographical exposure and compliance. Interesting, isn't it? Now I can bring all of this data to make my firm compliant across regulations and secure all of it to regulate performance, etc. But in addition to that, I also have some alerts coming through from machine learning for suspicious trading, for customer churns, etc. Now, to bring it all together in a single ecosystem, that is the power of the cloud. Now, keep this demo in mind as we get through the rest of the talk, and I'll try to tie it back to some of the aspects of this demo as we go through them, right? Switching back to my slides now. A quick overview of the architecture that's being thrown across as part of that demo. The data is actually getting raised from on-premises source as well as cloud sources. We're using Azure Data Lake's data management gateway to source all of that data into a single native store called the Azure Data Lake Store. From the Azure Data Lake Store, we're employing multiple analytics capabilities, be it Data Lake Analytics, be it Hadoop and HD Insight, or be it Spark and HD Insight. And then eventually publishing everything into the SQL Data Warehouse for our apps and dashboards to consume data from. For the real-time feeds, there is a hot path to that as well, where we bring it in via Kafka, in this case in HD Insight, employ Spark streaming to process the real-time streams as they come in, and then put it all back into the Data Lake Store for further analysis. For the machine learning pieces, of course, you have Azure Machine Learning and our server in scale-out mode, working across all of those analytics services. And as I said, nothing on this architecture diagram is actually outside of the cloud, except for the data generation that's happening from a variety of sources that coming through. Okay? Now, let's actually get to the real presentation pieces now. First, let's look at why. What are the benefits of running big data in the cloud? Again, let's start with what most of the companies are implementing today with the help of traditional clusters. Now, what does a traditional cluster look like? A set of compute servers connected between themselves, talking well amongst themselves, and then sharing a lot of resources for job executions, etc. When you need more compute power or more storage, you just keep on adding more nodes to your cluster. Now, what happens when you stop needing those additional compute nodes? What if your workloads are slightly seasonal in nature? Can you do away with all of those nodes? No, you can't. First, you've had to go through months of procurement cycles to even get those nodes, and now you can't even get rid of them when you don't need them. That's where the challenges of implementing on-prem clusters come in. First piece is upfront hardware costs. Costs thousands of dollars to go ahead and procure those servers for specialized execution of compute activities. Second, capacity planning. You cannot plan for what's going to happen 2 months down the line, let alone planning what I need today. You need to go ahead and try. You need to have a trial and error method to determine what the best performance of your cluster is going to look like over a particular workload and over a period of time as well. And the third piece, of course, the cumulative value of people sitting in this room is in an order of magnitude higher than any other room today outside of this arena. And I'm sure you guys agree to that. Just imagine hiring one of you guys to try and put in the expertise required from Hadoop or Spark perspective. That's expensive, mind you. What happens when you have Hadoop clusters in the cloud? Let's just start with IaaS clusters. And when I say IaaS, I mean infrastructure as a service. So you're just doing a lift and shift of your on-prem cluster as is onto the cloud, and you're trying to portray or take advantage of the elasticity or the flexibility of the cloud, right? You have a small cluster, you need more nodes, you keep on adding more nodes. You don't need the nodes, you just get rid of those nodes, because the cloud allows you to drop nodes as well as add nodes in its entirety. Now, what's the advantage? Well, there's no upfront hardware costs. You are in a subscription model. Second, you have unlimited scale. Just to quote some numbers over here, Microsoft executes exabytes of data on a cluster worth millions of nodes today on Azure. If you wanted to do it, any cloud provider could actually go ahead and support that. Now again, a quick disclaimer. I might refer to product names from the Azure perspective because I'm more familiar with them, but the topics in this talk are irrespective. They apply to all the 3 public clouds that we generically know, AWS, Google Cloud, or Azure. So if you have any questions or if you feel like you're not being able to correlate to something that you're implementing in the cloud, feel free to ask and I'd be happy to answer. Now, let's just take a deeper look at some of the attributes of some of these Hadoop or Spark clusters, right? In the first place, you have distributed storage. Of course, you need that because you get humongous amount of data. You cannot store it on a single node. There is no concept of SAN over there, so you need distributed storage in place. The second aspect, distributed compute. Well, you got a massive job. You got to split it into units that can be executed across multiple nodes at the same time, run parallelly, all right? So that's distributed compute. Third piece is, since you have so many aspects talking to each other, first the distributed storage, second the distributed compute, potentially the resource negotiator, etc., you need automated failover because you cannot have somebody sitting in front of a computer screen trying to manage when a failover happens and then you're taking some manual action on it. So you need automated failover. Then again, you need hyperscale. You cannot be restrictive. You cannot just say, okay, the max you can go is 10 nodes or 100 nodes or 1,000 nodes. I might need 2,000 nodes for 2 hours every night. I should be able to get it, right? That's the kind of scale that big data works with. And then it needs to be extensible. Who knows this better than this room? Every new day, a new open source tool. And there is a new language to learn, and there is a new capability to implement as part of your projects. So this entire infrastructure needs to be absolutely extensible. Now, what happens if I just take the slide and change the title of this slide from Hadoop or Spark clusters to the cloud? Does this still stand good? Distributed storage. Yes, you got an object store which is distributed in nature. Distributed compute. That's the parameter of cloud execution. Automated failover. Have you ever seen yourself taking any action when you deploy a cloud service and something goes wrong? It takes care of it itself. Hyperscale, of course. You cannot imagine the amount of compute capacity or the storage capacity that you can utilize as part of your cloud infrastructures. And then extensible. Well, be it Docker, Linux, or your traditional Windows environments, be it big data or your traditional data workloads, everything can execute side by side in the cloud. And the cloud moves faster to imbibe these capabilities than some of the most advanced corporations today. Okay? Now, what if big data on the cloud actually came together? It would actually take advantage of the compute capacities and the resource negotiations of the cloud, in addition or multiplied by the capacity and the resource negotiations of the entire ecosystem that you're trying to deploy on it. The point I'm trying to make is it's not a 1 + 1 = 2. It's actually 100 to the power 100, which is getting executed with big data in the cloud. Now, by now I've hopefully convinced you to stay throughout this conversation and not walk out on me midway through. Let's get to the second aspect of this discussion, what? Now, what are the options that we have to run big data in the cloud? There are three primary options that we have. One, being big data and IaaS, which is essentially infrastructure as a service. As I said, you could do a lift and shift. So you could just go ahead and pick up your on-prem clusters and say, okay, I don't want to run it on bare metal boxes. I want to execute them on VMs running on Azure or AWS or wherever. That's the big data on IaaS. And it has certain pros and cons associated to it as well. The pros, you have complete control. You can manage your cluster the way you were doing on-prem. You have all the knobs and dials and access to each and every element that you want to go ahead and adjust. Second, of course, on-demand cluster sizing. You need more nodes, you add more nodes. You don't need them, just delete them. The cloud takes it back. And then the storage. So now you can go ahead and leverage advantage of the cloud storage patterns as well. Right? In addition to, if you are familiar with local HDFS and you still want to persist with that, you can do that too. There are a few cons to the IaaS deployment mode. And then the cons, mind you, are in comparison to the other cloud deployment modes only. This is not a con as compared to, let's say, your on-prem clusters. There is no con as compared to your on-prem cluster if you're doing an IaaS deployment, because it's pretty much the same thing. Now, the cons for the cloud deployments is that as part of IaaS deployments, you deploy a particular distribution, which means the distribution provider is supporting you, not the cloud provider. The cloud provider is only supporting the infrastructure that you have deployed upon. Okay? The second aspect is there is administration still required. So you need to have that expertise for people to manage and deploy and keep on upgrading the individual bits up there. And the third piece, of course, the clusters need to stay active all the time, because if you're using local HDFS, you cannot delete clusters, expect the class or the data to reside and persist even after you delete those clusters, right? Let's look at the second deployment model. Big data and platform as a service, or PaaS. Many people call this managed Hadoop or managed Spark clusters. And this is the service where HD Insight and Dataproc and EMR actually sit. So what are the pros over there? It's a fully managed cluster service. It is an SLA-bound service. On Azure, it is SLA-bound. On some of the other clouds, it's not SLA-bound. The SLA is only applied to the underlying infrastructure. But for Azure HD Insight, the SLA applies to the individual core bits deployed as well. So if you're deploying Spark, you get an SLA for Spark. Deploy HBase, you get an SLA for HBase. Flexible resizing, of course, it's a slider up there. Either you just go ahead and enter the number of nodes, you can scale up, scale down, only restriction being the node type that you've selected while the cluster is getting created remains constant. The third piece being customizations. Now, a lot of you are going to come back and say, okay, now you deploy HD Insight with a certain set of bits. I need some additional ones because some of these open source developers have just come out with the latest bits in the Apache trunk, and I need those deployed on my cluster. Well, party on. Use script actions and customization options to go ahead and customize your clusters, right? Your clusters still remain supported. Only the additional bits that you deploy get supported by yourselves. Again, deployment. I've been playing around with big data since the last 10 years now. I remember 2007 when the initial Apache trunk was updated with the most stable bits. It took me about 7 months to get a 4-node cluster up and running, even talking to each other, to fire up the simplest of word count MapReduce jobs. Today, if I have to get a cluster up and running, I can do a few clicks over here. By the time I go grab a glass of water and I'm back, my cluster's up and running for me to execute my jobs on. From 7 months to 10 to 15 minutes, that's what big data in the cloud offers. From a cons perspective, again, you have to forego some control. So you don't have access to, let's say, for example, in a PaaS mode, you wouldn't want to deploy local HDFS. If you have some scripts that you've written only for local HDFS, you might have to go ahead and update that. So there are some things that you lose some controls on, which essentially means you're leaving it back to the experts to manage, okay? And then there is this third aspect, which is growing more and more today, which is big data as a service. Again, it's similar to PaaS, but it's a level above. In essence, here, you're not even worried about clusters. You don't think of big data as a cluster or anything like that. You just think of big data as a compute environment where you bring your query and you bring your data. And you fire your query against your data. So the likes of Azure Data Lake Analytics, the likes of Amazon Athena, which has just been introduced, I think, a couple of months back. And of course, the prevalent BigQuery. All of these fall under this particular aspect and this particular umbrella over here. So now, you don't have to worry about cluster, you don't have to worry about administration. You have a slider there to say, okay, how much power you want to associate to your particular query. In case of Athena and BigQuery, you don't even need to do that because they determine what is the best way to do or what is the optimal amount of compute to allocate to your query, right? And again, as part of that flexibility, you forego some more control. So now you don't have any more knobs and dials, you don't have any more administration pieces, you cannot see any more logs, etc. coming out of it. You just see your queries executing, whether they are executing in time or whether they are taking more time to execute, right? And then you have limited choice of tools. So not all languages can be run, not all of the open source ecosystem can be brought into the space as such. Let's quickly take a look at what these options look like in a typical cloud environment. So in this case, I'm just going to go ahead and say, okay, here I have my Azure portal up. I'm going to go ahead and say, Marketplace, go find me Hortonworks. It has Hortonworks Data Platform Standard deployed. Just go click on it, say create. It asks me a few questions. In a span of a few minutes, I have my IaaS cluster up and running. Similarly for HD Insight, let's just go ahead and cancel this off. And mind you, it's not just Hortonworks. You can go ahead and deploy Cloudera or Mappa or whichever distribution you want on IaaS over here. Let's get to HD Insight, which is the managed cloud service over here. Again, you want another cluster, come in here. answer a few questions, you have it up and running. What does it need? Well, it just needs your basic settings. It needs a storage account associated, and it needs a summary slide which says, okay, here is what we are deploying. Do you want to change anything? Well, I want to change my compute node type, or I want to change the number of nodes in my cluster. I can go ahead and do that. Let's take a look at one that is actually running right now on the Azure. So here is one of my Spark clusters that are actually running. I can go ahead and click on Cluster Dashboards. It provides me with a number of dashboards that I can play around with. If I want to see certain heuristics of the cluster, I can either access the cluster dashboard or the Ambari dashboard. If I want to see the Spark history server or the Yarn server in Ambari, I can go ahead and directly link back to it. What's interesting is it also provides me with two REPL environments, one with Jupyter notebooks and one with Zeppelin notebooks, which are deployed as part of the cluster automatically. You don't need to do anything special to do that, which essentially means that in that span of 10 or 15 minutes, your analysts and your data scientists and your data engineers are now up and running with your Spark requirements. They don't need to deploy anything further to get started. Just to show you some of those environments up here as well, here is a Zeppelin notebook executing on Spark. Here is a Jupyter notebook executing on Spark in HT side. As simple as a few clicks, as I just showed you. Now let's get back to the Azure and see what does big data as a service look like. Well, let's just go ahead and click on this one. I have one of my data lake analytics accounts deployed. Again, talking about big data as a service. It provides you with the capability to just go ahead and fire up jobs. So let's just go ahead and say sample scripts. And copy the sample data. And then you can go ahead and fire up a query against the sample data. Again, querying against your data is as easy as writing a SQL statement against it. Now, with Data Lake Analytics, we use a language called USQL, which is bringing together the descriptive nature of SQL with the integration capabilities of C# so that you can take advantage of all of the work that you've done previously and even extend it for other languages like R, Python, and cognitive services, right? Just to show you some of the developer tooling around this, well, here you have some of the Visual Studio capabilities. This is a job that executed as part of the demo that we saw in the beginning. I can actually play back this demo to see what the bottlenecks were. Mind you, this job took about 8.5 hours to execute, and it can play it back to me in a span of about 1 minute for me to identify bottlenecks as well as see any other metrics that I want to. It also provides me with the machine learning-oriented diagnostics, where it provides me a status of what was the usage of the compute capacity that I attributed to it, and what I really need to do to even fasten my jobs if I need to, right? Now, just a glimpse of what we have as part of all of the three capabilities. Now, let's get back to the slides here and probably see some of this and understand it a little better. I hope I gave you a good glimpse of all the three modes of deployment over there. If you have any questions, happy to answer them. Let's look at some of the deployment modes or reasons for hybrid deployments as well. So a lot of customers actually come to us and say, okay, cloud is great, but we already have an on-prem environment. We actually want to deploy it in a hybrid nature. And most of the common reasons are these three. So one is you have a specialized workload. Now, you've been doing a lot of batch mode processing on-prem. Now you've suddenly got a machine learning workload. You don't want to upgrade your servers or your clusters for the newer capabilities of machine learning. You want to take advantage of some of the cloud capabilities. You want to go ahead and design a hybrid deployment. The second one being bursting. Well, I have a 40-node cluster, but every week or every weekend, I need 400 nodes to go ahead and integrate all of that data processing across the week or even integrated with the data from the entire month or the year. Now, where do I get that? Do I get a 400 node clusters, whereas I only need to utilize that for a span of 7 hours in a week? Doesn't sound right, right? That's where Cloud Burst comes into the picture. And then the third one is, of course, backup and archive. So I have a lot of data, but I don't make use of any data that is older than, say, 18 months or, say, 4 years for compliance reasons. Can I back up an archive, and can I still be able to query that data whenever I need to, if I need to report upon it? That's where backup and archive comes into the picture. For the first two, it is important that your data is replicated across on-prem and the cloud, because both specialized workloads and Cloud Burst require you to have the data so that you can process that data using compute capabilities. The hybrid nature can be deployed using tools like Falcon and Azure Data Factory, which are integrated amongst themselves, so that it allows you to go spin up a cloud cluster when you need to on the integration of an event. And when you have that cluster deployed, you can then process everything in the cloud, bring the results back to your on-prem cluster to report upon. In a lot of cases, security concerns also govern this kind of cloud bursting or specialized workload execution. So I cannot move certain attributes of my data, but I can move the rest of the attributes of my data to the cloud. Go ahead, execute certain attributes on-prem, deploy the rest of the attributes to be executed on the cloud. That's where, again, Cloud Burst and specialized workloads really come into the picture. A very common mode of deployment today for our customers as well, with Data Factory being the data management gateway across the on-prem and the cloud, and then even Polybase, capabilities like Polybase and federated query, allowing you to query that data from your relational workloads like SQL Server into your Hadoop environments like Hortonworks Data Platform or Cloudera or HD Insight in the cloud. So allowing you to create that entire end-to-end modern data warehouse, so-called infrastructure. Okay? Now let's take a look at what the clusters actually look like. Well, this is a typical on-prem cluster, right? You have a head node, you have a bunch of data nodes. Each of those data nodes have tasks allocated to them. They have storage capacity, which serves as the HDFS layer. What do clusters look like in the cloud? If it's an IaaS cluster, well, just lift and shift of the same on-prem cluster to the cloud. But if it's an actually PaaS or a big data as a service environment, you have compute and storage separated. I see a few eyes popping up. Are we defying the whole principle of bringing compute to the storage? Well, that principle was designed 12 years back, when networking technologies and cloud were unheard of. Today, all of these capabilities have taken an order of magnitude advancements in the speed as well as the execution capacities. And as such, separating them makes much more business sense as well as technical sense than they made 15 years back. We'll take a look at some of the intricacies of it, but just to introduce HD Insight that we've been talking about for so long. 100% open source service based on the Hortonworks Data Platform. Again, it's a managed cluster service. It's running clusters up in minutes. You can execute your jobs whatever you need. Specialized jobs have specialized cluster types so that you don't have to negotiate between any kind of cluster resources between the cluster types. Okay? Coming to the HD Insight clusters architecture, it's pretty simple. You have a data gateway. You're bringing that across your data nodes. You have all the tools deployed on it, but the storage resides separately, either as Azure Data Lake Store or the Windows Azure Storage Blob. Both of them can act as the HDFS for your HD Insight clusters. Now, what's the advantage of it? Your storage resides separately. You can just spin up your cluster and spin it down when you don't need it. Your storage still persists, and you can still have your BI tools and reporting being done from your storage environment as you need it. What's the security model for this? Well, HD Insight clusters are integrated with Azure Active Directory. They also talk to Apache Ranger. So now the VNet in which the HD Insight clusters were residing can now go ahead and take advantage of all the capabilities of Azure Active Directory's roles, groups, and access levels, and then bring it all back via this VNet pairing across multiple clusters as well if you need to, right? Now, that's great for clustered architecture. What about big data as a service? Well, in big data as a service, as I said, you're just firing up a query, right? So your user requests a query, be it in USQL or be it in Python or R or whatever. There is a pool of compute resources already available, as you see up top. When that request comes in, it also comes in with a number of compute resources associated to it, and those get associated for the compute environments, which then further goes ahead and access the data storage environments and sends the results back. Once the compute is over, you can return those compute resources back to the pool and the results back to the user. That's the advantage of big data as a service as a whole. So you're not spinning up any clusters, you're just borrowing compute resources for a specific amount of time till the query executes, and as soon as the query executes, you're throwing it back up. Decoupling compute from storage. Questions, of course, bandwidth, latency, consistency. Answers, definitely there. Bandwidth, as part of the Azure Flat Network, you have 50 terabytes plus of aggregate bandwidth. It has HDD like latency, which means local HDFS, literally. Strong consistency because the cloud storage environments already have a replication factor. And if you want, you can even geo-replicate your data across different data centers. Coming to the benefits, well, there are benefits across all of the workloads, be it batch processing, be it NoSQL processing, or be it stream processing. One is, you just need the clusters up and running when you're executing. You can spin them down when you don't need them because the storage is separate, so you don't need to keep the storage environment or delete the storage environment even though you're deleting the clusters. For the streaming workloads specifically, and for some of the specialized workloads, the resource negotiations can happen much more effectively when you have compute and storage separated. For example, a edge-based cluster might need you to have a 400-node cluster just because of the storage limitations on a single node. But in this case, you could have a 10-node edge-based cluster with a humongous data lake store associated to it because the compute capabilities are sufficient for that 10-node cluster to execute on top of it. Getting to the data lake store, again, a hyperscale storage environment, which is bringing that in, and then the cluster customization options as well that I talked about. Now, as we talk about cluster customization options, there are various stages to a cluster deployment. The cluster customization actually happens after configuring HD Insight, which essentially means that you're deploying all the big data bits on top of Azure VMs that form part of the cluster. So now you can go ahead and deploy, say, Flink or Presto or, I don't know, what's the newest animal in the zoo, which is not currently possible in HD Insight. You can just go ahead and deploy that as part of it. Cluster integration options, a lot of them. Coming to the architectures of cloud deployments, it's a simple big data application architecture. You bring it into the storage environment, you use compute resources. Oh, okay. Right. Apparently the time is up, it seems. And they want me kicked out of here. But pretty much similar to the application architectures out there. Oh, they brought me back up. Thank you. Just give me a quick minute here so that I could walk through the architectures at least. But the cold path and the hot path of deployments in there. So you could bring in streaming as well as the batch mode processing. And then you have orchestration tools around that. What does the Azure architecture look like? This is what it comes out to be. You bring in all of your data via your ingestion tools into Data Lake Store. You use either Data Lake Analytics or HD Insight to process your data, and then leverage the SQL Data Warehouse as your publishing layer. If you want a more detailed architecture, pretty similar to the one that we saw for the app up there as well, right? And then, of course, all of this need not be procured individually. Usually, all of these cloud environments offer suite capabilities to give you all of these capabilities as part of a single SKU. In case of Azure, it's the Cortana Intelligence Suite, which has all of the capabilities that we talked about today. Again, big data being the cornerstone of that particular suite. Just to summarize, here's the summary slide up here for all of you to take away. And again, if you want to get started, here are the 2 links that you need to get to before you can walk out of the room. Thank you so much for giving me a patient hearing. Thank you.